Today we're looking at this webinar, Wireless Connectivity, Enabling the Next Industrial Revolution. It's from the Alpert research team. And it really dives into the convergence of wireless communication with Industry 4.0 and 5.0. Okay, so we've covered the technologies and their powerful capabilities. What does this all mean when we bring it back to the factory floor, to the warehouse, to the actual supply chain? How do all these sophisticated wireless technologies translate into tangible value and real-world impact for industries, both right now and looking into the future?
These technologies aren't just theoretical marvels, they are actively enabling fundamental shifts across industrial operations and driving real measurable value. The Industrial Internet of Things, or IIoT. It's all about connecting physical devices, sensors, actuators, machines, everything from a tiny temperature sensor on a motor bearing to an entire complex production line to enable real-time data communication and control across the industrial environment. These devices overwhelmingly rely on wireless links. Maybe it's Wi-Fi for high bandwidth data from a machine vision camera, perhaps an LPWAN for monitoring remote tank levels, or increasingly private 5G for mission-critical control signals to robots or AGVs. Wireless is needed to transmit that real-time data reliably. This forms the very foundation for data-driven decision-making, optimization, and automation. Wireless IoT is also essential for that flexibility we talked about, easily attaching sensors to mobile machines, reconfiguring sensor layouts, or monitoring assets in hard-to-reach places without running cables. It fundamentally automates the data flows that optimize scheduling, quality control, and overall throughput in smart plants. Digital twins are essentially dynamic virtual replicas of physical assets, processes, or even entire systems. It could be a single machine, a specific production line, a whole factory, or even a product out in the field. The key is that these virtual models are continuously updated in real time or near real time, with data streamed from their physical counterparts via sensors. To enable simulation, testing what-if scenarios virtually, monitoring, visualizing real-time performance, analysis, identifying anomalies or inefficiencies, and optimization, finding better ways to operate, all within a safe virtual environment before implementing changes in the real world. They require low latency, high reliability, and often high bandwidth wireless connectivity. Technologies like 5G or LLC or high-performance Wi-Fi like 6E or 7, potentially with TSN integration, are crucial. This ensures synchronous updates between the physical and digital and allows for high-resolution mapping and visualization, making the virtual twin truly reflective of the physical reality at any given moment. Edge computing involves processing data physically closer to its source right there on the factory floor. The primary benefit here is drastically reduced latency. This is vital for applications where speed and precision are paramount. Cloud platforms, on the other hand, provide virtually unlimited, scalable, and centralized resources for heavier, more complex analysis, long-term data storage, training sophisticated AI models, and performing global optimization across multiple sites or the entire supply chain. Wireless links are the critical connective tissue in this architecture. They provide the high-speed, low-latency, and reliable communication needed to seamlessly connect the physical assets to the edge devices, enable communication between edge devices, and link the edge infrastructure back to the central cloud platforms, and vice versa. They facilitate that localized data processing right where the action is, allowing critical decisions to be made in milliseconds, while also ensuring that relevant data is aggregated and sent to the cloud for deeper insights. Artificial intelligence algorithms and big data analytics platforms are essentially the brains that process and extract value from the massive data streams generated by these pervasive wireless sensor networks and connected machines. This enables powerful capabilities that transform industrial operations. Wireless technology is the fundamental enabler here. It's what reliably transmits this vast amount of diverse data, from tiny sensor readings to high-resolution video streams, from the myriad of devices on the factory floor to the edge and cloud platforms where these powerful AI and analytics engines reside. Without robust wireless connectivity, you simply wouldn't have the timely, comprehensive data needed to fuel these intelligent systems. Cyber-physical systems, CPS, characterized by a truly tight integration and feedback loop between computation, the cyber part, and the physical world. Physical processes and objects. Pervasive, reliable wireless connectivity is the lifeblood of these CPS. It provides the constant stream of real-time environmental and operational data position, temperature, pressure, images, forces needed for the computational elements to understand the physical state and make intelligent control decisions. It also provides the channel to send commands back to the physical actuator. Wireless effectively blurs the traditional lines between human and machine and between the physical and digital domains, enabling this deep integration. Fostering true human-machine collaboration, moving beyond simple coexistence to active partnership. The aim is to leverage the complementary strengths of both humans and machines. Humans are freed up to perform tasks requiring creativity, critical thinking, complex problem solving, dexterity, or adaptability, while robots, particularly collaborative robots, cobots, handle the tasks that are physically demanding, highly repetitive, require extreme precision, or operate in hazardous environments. Ultra-reliable, low-latency wireless communication, like 5G URLLC or deterministic Wi-Fi, is the key technical enabler for safe and effective collaboration. It allows cobots and mobile platforms like AGVs to work safely and intelligently right alongside human operators, reacting in milliseconds to human movements, gestures, or explicit commands without the need for physical safety cages in many scenarios. This seamless, untethered interaction facilitated by high-performance wireless is what makes human-robot teams truly effective, flexible, and crucially safe. Augmented reality (AR) and virtual reality (VR) are rapidly moving from niche applications to becoming indispensable tools across the industrial lifecycle, and they simply wouldn't be practical or effective at scale without high-performance wireless connectivity. High-bandwidth, low-latency wireless connections, think 5G millimeter wave for its massive bandwidth, or Wi-Fi 6E7 with features like multi-link operation (MLO) for robustness, are absolutely essential for delivering seamless, high-fidelity AR/VR experiences. They enable real-time information overlays to appear instantly and track smoothly as the worker moves their head. They allow for high-resolution holographic telepresence, where remote experts can virtually be present and interact with local environment. And they ensure that these computationally intensive, immersive applications run smoothly without perceptible lag or motion sickness, which is critical for usability and adoption. Wireless essentially untethers these powerful visualization and collaboration tools. All these technologies and applications converge in the realization of smart factories. These aren't just factories with automation. They are truly intelligent, interconnected environments where machines, sensors, systems, and even humans are constantly communicating and collaborating, enabling continuous monitoring, analysis, control, and optimization across the entire production process and value chain. Wireless connectivity in its various forms forms the very backbone, the central nervous system of these smart plants. It automates the critical data flows that are needed to optimize production scheduling in real time, implement sophisticated quality control measures, predict maintenance needs, manage energy consumption efficiently, and maximize overall throughput in ways that were previously unimaginable with siloed systems and manual data collection. Another direct and highly significant value driver enabled by wireless sensing is predictive maintenance. PDM uses smart sensors, monitoring vibration, temperature, acoustics, oil quality, etc., and sophisticated analytical techniques, often involving AML, to continuously track the actual health and performance of equipment in real time. Wireless predictive maintenance systems are key because they allow sensors to be easily deployed on critical assets, even rotating or mobile ones, to continuously transmit machine health data to central analytics platforms. Asset tracking and supply chain visibility are being completely transformed by wireless technologies. This involves achieving real-time or near real-time tracking and monitoring of goods, assets, containers, and vehicles throughout the entire supply chain. Technologies like LPWANs, LoRaWAN, NB-IoTs, Sigfox are ideal for tracking assets over long distances with long battery life. Cellular IoT, NB-IoT LTM, provides broad coverage, often leveraging existing cellular networks. Bluetooth Low Energy, BLE beacons, are great for localized tracking within warehouses or yards. And even satellite IoT comes into play for truly global tracking where terrestrial networks aren't available. Wireless connectivity combined with automation and data analytics enables a fundamental shift towards highly flexible, mass-customized production. This facilitates on-demand manufacturing and highly adaptable production processes where products can be individually tailored to specific customer requirements without sacrificing the efficiency and speed typically associated with mass production. The seamless, real-time interaction between machines, and critically the close collaboration between humans and machines, fostered by reliable wireless communication, creates the agility and information flow needed for this level of dynamic customization. Furthermore, wireless connectivity and the data it enables are fundamental enablers for entirely new product-as-a-service business models. Wireless provides those seamless, low-latency links needed between the physical assets, the edge processing devices performing immediate control and analysis, and the cloud platforms used for broader analytics, service provisioning, and long-term optimization, making these sophisticated data-driven business models feasible. So, Industry 5.0 isn't just some far off idea anymore. It's actually happening now, it's evolving, and wireless communication is right there at the heart of it, enabling it all. Organizations that really lean into wireless innovation, they're the ones who will unlock smarter production, more resilient supply chains, and ultimately create value that's sustainable and human centric. As this whole industrial landscape keeps shifting towards being more autonomous, more intelligent, more adaptive, well, how quickly and effectively companies adopt and integrate these wireless technologies, that's really going to shape their competitiveness long term. If you're interested in digging deeper into this whole transformation, we absolutely recommend checking out the full analysis. It's titled Wireless Connectivity, Enabling the Next Industrial Revolution, prepared by the Alpert research team. You can find their presentation on the future of the wireless industrial revolution at the link provided in our show notes.